Okay, so today we're going to introduce trigonometry. And I want to give you a little background stuff first. We've talked previously about some right triangles, specifically dealing with the Pythagorean theorem, and our special right triangles, 30, 60, 90s, and 45, 45, 90s. And if I tell you that I've got a 30, 60, 90 triangle here, and I tell you that, for example, this side is 5, how long is the hypotenuse?
Ten.
10. And if I gave you a different 30, 60, 90 triangle over here, and I told you that this side was 1, how long would this hypotenuse be?
2.
Yes. And that would be true for any 30, 60, 90 triangle, that the ratio of this side over this side would be 1 to 2, right? 5 to 10 reduces to 1 to 2. No matter what the sides are, they will be in a ratio of 1 to 2 if it's a 30, 60, 90 triangle. Agreed? So if you think about it, that same reality must be true for all triangles. Like, for example, if this were 24 degrees, then I don't know what these two things would be, but their ratio would be consistent. While the individual numbers might be different from here to here, the ratio between these two would be the same, just as the ratio here is the same, because the triangles are similar. Well, it turns out there's a way that we can identify the relationship among those using our trig functions, sine, cosine, and tangent. And that's what today's lesson is about. Before we go there, we have to talk a little bit about what a degree is. What is a degree? And I am referring to angles here, not temperatures. What do you think? What's a degree?
The measure of an angle, the unit for the measure of an angle.
Okay, good. It's how we measure angles, isn't it? And when we talk about a particular angle, we might say that this one is whatever, 20 degrees. But degree is kind of like foot. It's kind of like mile. It's a unit of measurement. And at some point, we have to define what that is. Like, what is a foot? Well, it was some king's foot size from a long, long time ago. And so what's an inch? Well, it's 1/12 of that fixed measurement. And what's a yard? Well, it's 3 of those. So in the same way, a degree is actually when you take a circle and you slice it up specifically into 360 parts. Right? There's 360 degrees in a circle. Therefore, 1 degree is 1/360th of a circle. And that's all it means. But the important thing is that we do recognize that a degree is 3/60th. It's possible we could use something called a radian. And what a radian means is I could take this circle and instead of splitting it up into equally 360 parts, I could split it up into 2 pi parts. A little more than 6. 1, 2, 3, 4, 5, 6. And there's a value to that. Those are called radians, and there's a reason we'll use that in pre-calculus and in advanced algebra a little bit. And there's even something called gradients, which are more used in engineering, but really they're like a pie chart. Each one is 1/100th, so it's like a percent of the shape. And all 3 of these are valuable in their own way, but the trick is we got to make sure that we're telling our calculator for this unit which one we're looking at. So what you'll find is that most calculators have a little button here, DRG, and then up on the screen, it pops out with like a DEG or an RAD or a GRD as necessary. Excuse me just one second. Okay, so in the calculator, you've got this button. Usually it's a DRG button. It's different. Let's see what this one is. Mine up here is on the little green thing up here. I'd have to press third and then get to it. But what it does is it's going to toggle the display between RAD, GRAD, and DEG. And it changes entirely the way your calculator functions. So it's really important that we get this right. We want to have degrees selected, not radians or gradients. The easiest way to test this is to recognize that we know that in a 30-degree triangle, this opposite side over the hypotenuse will equal 1/2. In terms of the sine world, that means that sine of 30 degrees will equal 1/2 and will show up on your calculator as 0.5. So I want everyone to test their calculators right now by doing this. And this is going to do two things. One, it'll validate that your calculator is set correctly. And two, it'll make sure that you know how to use your calculator for doing this kind of operation, because there are different types of calculators out there. So in my case, for this particular calculator, I'm going to press clear, and then I'm going to press 30 for the 30 degrees, and then I immediately press the sine button. And it will calculate for me that it's 0.5. That tells me that I have to enter in the degrees first, and then the symbol, or the trig function, to get my answer. Whereas on an iPhone, it's the same way. I'm going to start by saying, okay, this screen doesn't have enough features in it, so I'm going to turn it sideways and make it look like my comprehensive calculator. And when I do 30 degrees and then press sine, I should get 0.5. If when you press 30 degrees and then sine, you get that, that's because your calculator is set to the wrong thing. See up here it says rad. So you have to come down here where it says degrees, DEG, and change it to DEG. Now when you press 30 sine, you'll get 0.5. There are other types of calculators like these TI. My batteries just ran out this morning, but this one you actually press sine, then 30, then enter. But I need to make sure that everybody in the classroom now has the ability to calculate sine using degrees. Anybody need help with that?
Yeah, could you go over it on the phone one more time?
Sure. So pull up the calculator and then turn it sideways so that you get the long calculator. And if you've got your screen locked, then it won't let you do that. So you'll have to change your screen from being unlocked. And if I want to take 30 degrees and sine it, I first do the 30 degrees, and then I press the SIN button right there. And that gives me 0.5. If for some reason you've got RAD showing up on your screen here because this button got mistakenly pressed, then when you try to do that, 30 degrees sine, you'll get a big negative decimal. That's not what you want. So you'd go back to pressing that button so it then is gone. It's now, you select the button if you want radians, or you select the button if you want degrees. I think that's backwards, but anyway, when it's not showing up there, you do 30 sine, and it should come out to be 0.5.
Okay, thank you.
Yeah. All right, so what's the point of all this? Well, the point is that we can now, using this science, trigonometry is a type of science, we can use this to tie up the relationships between sides and angles, which we've never really been able to do before. We had great information about sides. We could do Pythagorean theorem. We had good information about angles with the triangle angle sum theorem, but now we're putting those things together. So trigonometry is the study of geometry, the relationships between angles and sides in a triangle. And what it means is that if I take the sine of an angle, right? An angle is a numerical value. Maybe it's 30 degrees, maybe it's 27, maybe it's 26.93. And if I do this mathematical operation to it, each one of these will do something different. The sine of an angle will take that angle measure and translate it to give you the ratio of the opposite and the hypotenuse. So for instance, if I take the sine of this angle A, relative to that angle A, this side, little a, is on the opposite side of the triangle. C is the hypotenuse. It's always called that because it's opposite the right angle. And B is adjacent to angle A because it's touching. So if the sine is the opposite over the hypotenuse, then the sine of angle A would be A over C. And then the cosine of angle A would be the calculation of the adjacent side over the hypotenuse. So that'd be B over C. And the tangent operation takes that same angle and it just gives you the ratio of the opposite side to the adjacent side. So A over B. In other words, it magically changes an angle into the ratio of the sides. It talks about the relationship between angles and sides. It does matter where the angle is. So instead of looking at angle A, if I were to change my perspective and look from angle B, I'd notice that the opposite is different. Opposite of angle B is little b. The hypotenuse is still the same, but since sine is the opposite over the hypotenuse, it would be B over C. And then the cosine would be the adjacent over the hypotenuse, so that would be A over C, and the tangent would be the opposite over the adjacent, B over A. Now, what I just threw at you there is a ton of stuff to have to think about. Opposite angle and which angle, and is it opposite, adjacent, or hypotenuse? And then there's sine, cosine, and tangent. It's a lot to memorize. So we have a mnemonic that helps us do this. This is arguably the most important part to remember in trigonometry. It is so hard to remember that we really have to think about a way to do it so that we can remember. So, ka, let's go with red for the last one, and toa. Now, it's an acronym of sorts, right? It's a mnemonic device to help you memorize something. It doesn't stand for anything, it doesn't mean anything. I can tell you a story about it, right? Last night I was trying to set up my new Alexa. I've got the smart bulbs and I was trying to set them up so that all the lights in the house go off at the end of the night. And I was in my room and I said, Alexa, turn off all the lights in the house. And Alexa did exactly as I asked, but of course now I'm stuck in my bedroom with no lights on and I can't see where the lights are, and I don't want to turn them on by Alexa because then it'll turn them on in the living room. My whole point was I want to check. So anyway, I'm like trying to work my way out of my room without killing myself. And what do? I kick my toe in the corner of the bed. You ever do that, right? Where the little wheel is and you jam your baby toe full force because you're moving that foot forward. It hurts so much. And all you can do is take out a bowl of warm water and stick your toe in it and you soak a toe. And sometimes that helps make it feel better. Sometimes people hear that joke and say, Mr. Erlin, your jokes, they're so bad. They're so katoa. I need this phrase. Thank you, Luke. I appreciate that. I need this phrase to resonate in your head the way a bad song does. So katoa. To ensure that that happens, for about the next 10 minutes, every time I say the word so, I want you to interrupt me by saying katoa. First person to interrupt me by saying katoa wins a point. Points mean nothing. However, I want you thinking about saying so katoa. And you'll discover as you hear this how often I use so as a transitionary word. Okay, so see that? Come on.
Katoa.
Thank you very much. What this stands for is that so tells us that if we take the word sine, that it's the ratio of the opposite over the hypotenuse. So means sine is opposite over hypotenuse. Ka means the cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. Why is that useful? Well, because if we're trying to establish what the sine of A is, step one, I make that my angle. That's what I'm looking from. That's my perspective. And then I have to say, relative to that angle, what side is opposite? Well, 12 is next to it, 13 is next to it, but more importantly, the hypotenuse. So this one earns the adjacent name, this one is hypotenuse, and way over here is opposite. And if I'm taking the sine of angle A, that means I want the ratio of the opposite over the hypotenuse. 5 over 13 is the sine of angle A. What would the cosine of angle A be? Well, that would be taking the adjacent side over the hypotenuse. So that'd be 12 over 13, whereas the tangent is the opposite over the adjacent. So just going to leave a so hanging out there, begging to be interrupted. Okay, I'd like you to try this one, please. Please do this row yourself. What's going to change is that now your perspective is from C. And while the hypotenuse will remain the same, this will no longer be an opposite side. This will now be the adjacent side. And this will now be the opposite relative to angle C. Please fill in sine of C, cosine of C, and tangent of C. Okay, let's take a look. Sine of C, that's opposite over hypotenuse, so that would be 12 over 13. Cosine of C is the adjacent over the hypotenuse, that would be 5 over 13. And tangent of C would be the opposite over the adjacent, so that would be 12 over 5. If I were to ask you to do that for number 2, you'd run into a problem. What's the issue with number 2?
Missing a side.
It's missing a side, isn't it? We've only got 2 sides, so we'd have trouble doing it for part of it. Can we find this missing side?
Yes.
Good. How?
Pythagorean theorem.
Right. So I could say 9 squared plus 12 squared equals C squared. 81 plus 144 equals C squared. 225 equals C squared, which means C is equal to 15. And that works. Turns out there's something I haven't told you guys about called a Pythagorean triple. And what that means is that the numbers are nice whole numbers like 5, 12, and 13. Those will work for a right triangle. Could I have a right triangle with 6 here and 12 here? I could, but my hypotenuse would then be like 13.97321671423. It would not be an integer. But when they're all integers, those are called Pythagorean triples. And the most obvious one is the 3, 4, 5. That's the one my buddy John McGovern, a contractor who really never liked school, but he knows 3, 4, 5 triangles because he can use them on a roof to make a right angle. 5, 12, 13 is another one. There's about 5 or 6 that people often think about, but usually 3, 4, 5 is the most common. And look at this. This is really 3 times 3. This is really 3 times 4. This one is really 3 times 5. So we could have found it a little bit faster. This one is 8 times 2. This one is 17 times 2. This one is going to be 15 times 2, because I happen to know that 8, 15, 17 is a Pythagorean triple. So anyway, with these numbers in place, can you guys please do W and X? Find the sine, cosine, and tangent for each one. Go. All right, let's see how we did here. Can I get a volunteer to please give me the sine of W?
(12/15).
12/15 is correct. It does say its simplest form, so theoretically we should reduce this to 4/5, but I kind of like 12/15 because it shows which sides you're using. What about the cosine of W? Is that Luke's hand up?
No, I can't.
Is that a hand, Luke? You can give me the answer?
Yeah, 3/5.
Excellent. So it's 9/15, which is the same as 3/5. What about tangent of W? Keep going, Luke.
12/9.
12/9, which reduces to 4/3. Excellent. Okay, and let's crank through the X over here. The sine of X would be going from this perspective now, so it'd be 9/15, which reduces to 3/5. Cosine of X is 12/15, which is 4/5. And tangent would be 9/12, which is 3/4. How's that feel for you? 5, I think I can do these very well. This makes sense to me. 3, I still have to keep looking at the SOHCAHTOA, but I think I can do this. 1, I'm not understanding. Okay, good. I'm looking at the groups by cohort, and I don't have many people with computers. So Colette, it looks like you've got your computer out, and if you want to send me a message and go Guardian, you can. If the rest of you are interested in opening up your Chromebook so that you can communicate with me, you can do that. Okay. All right, let's go through this one real quick and do it one more time. So sine of L, this is our perspective here. I'll use a better color. So we're going from L, sine is opposite over hypotenuse. So that would be 30/34, which is 15/17. Cosine of L would be 16/34, which is 8/17. And tangent of L would be 30/16, which is 15/8. Sine of M, we change our viewpoint, so the sine is 16/34, which is 8/17. Cosine is 30/34, which is 15/17. And tangent is 16/30, which is 8/15. Okay, so what? How is that helpful to us? Well, let's go to page 2. We can use this to solve problems. In other words, find missing sides or missing angles. So here's what we're going to do. I'm going to write out the step-by-step that you should do with this. Step 1, which angle? Okay, so notice here, we've got this angle selected, so that's the angle we're looking at for perspective. Step 2, which sides? O, A, or H? And of course, this all depends upon which angle we chose. So going from this angle's perspective, what do we call this side, the 19? Is that opposite, adjacent, or hypotenuse? It's the hypotenuse. That one's easy because it's always the same. But for this other one, I have to look at, in this case, the x. I want to get the x in my equation. So that's the side I want to look at. relative to the 28, is that the opposite side or is that the adjacent side?
Opposite.
Good. So once I establish that I've got O and H, I have to ask myself, 3, which trig function? And this is SOHCAHTOA. So if I've got O and H, what goes in front of that? S, C, or T?
S.
Yeah. That tells me it's SOHCAHTOA. Therefore, I'm going to write out, let's go with red here, write out equation. So what that means for me here is I recognize that this means it's sine, so I write the sine, S-I-N. And always, always, always after that, I put in the angle measure, in this case, 28 degrees. And it's going to equal the ratio of those two sides, top to bottom. So in this case, it would be opposite x over 19. That's my trig equation. And now I need to solve it. So step 5 is solve. So the way I'm going to solve this is I'm going to put this over 1 and cross multiply, and I'll get x is equal to 19 times sine of 28 degrees. Notice that I'm not writing the 19 next to the 28 because I don't want to multiply the number of degrees by 19 and then take the sine of that. I want to multiply 19 times the product or the whole element here, sine of 28. And then I can take out my calculator here. And if you've got a calculator like mine that requires you to do 28 then sine, you could do 28 then take the sine of that. That tells you that little chunk and multiply that times 19. Therefore, x is equal to 8.91996, but it said the nearest tenth. So I'm going to call that 8.9. Give you a moment to catch up. Okay, let's try number 5. So step 1 is I have to identify where the angle is. Okay, it's down here. Relative to that, that tells me that over here is my opposite and this is my adjacent. If I'm dealing with opposite and adjacent, SOHCAHTOA, that's tan, okay. Step 4, write out the equation. Always, always, always after the tan part comes the degrees, 41 equals opposite over adjacent, so x over 32. Last step is solve. Cross multiply. X equals 32 times tangent of 41. I'm a bit of an advanced user on my calculator, so I'm just going to do 32 times 41 tan and then hit enter. And that's going to give me 27.8. Okay, let's try one more down here. So here's my angle. That makes this adjacent and hypotenuse. Adjacent and hypotenuse, that's a ka. So I can say that the cosine, and always, 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 after the trig function comes the angle measure. So 21 equals adjacent over hypotenuse. cross multiply. Pull out the calculator. Make sure if you're trying to do it in one thread like I'm doing it, make sure that you hit equals at the end. All right, this is what I consider level 1 solving with trig. What's your confidence level? 5, I can do these easy. This makes perfect sense to me. 3, it's all right. I do have to look at some stuff and kind of make sure I understand what I'm doing. 1, I'm kind of confused. Okay, we need some practice, it looks like. That's good. Now, level 2, I'm going to introduce here. Actually, no, this one's still level 1. Do this one, please, yourselves. Do number 7. Go. All right. Hopefully you identified the angle, saw that x is opposite it, 8 is adjacent, not the hypotenuse. Therefore, it's an OA. So we call it a TOA, which means it's tangent. Always, always, always after the trig function comes 55 degrees, and then it would be opposite over adjacent. This can be solved by cross multiplying. And we plug that into our calculator. 8 times 55 tangent, and then equals 11.4. How many got it right? 5, I got it right. 3, I got really close. There was one little mistake. I think I could get it right next time. 1, I didn't know how to do it. I'd love to see that in direct messaging, even if you don't want to share it with everybody. Okay, so now I'm going to move on to what I call stage 2. And the geometry, the trigonometry really of it, is exactly the same. I start off identifying my angle. I then say this is my opposite, this is my hypotenuse. I know that so is the trig function that goes with opposite and hypotenuse. Therefore, I'm going to call this the sine. The sine of 33 is equal to 15 over x. So all that looks the same. The only piece that's different about it is that when I do my cross multiplication, I end up with a bit messier result. All for these first examples, one cross multiply and I got x equals. This one, when I cross multiply, the x multiplies times the sine of 33, equaling 15. The sine of 33 is a number. I could plug it into my calculator and find out what it is, approximately. So what I want to do is say if x is being multiplied by this, but I only want one of them, then I need to divide both sides by the sine of 33. On this side, they will cancel, leaving me with what I wanted, just x equals. And on this side, it would be 15 divided by the sine of 33. 15 divided by 33 sine, and then I hit enter, 27.5. X is about 27.5. So again, step 1 is the same, step 2 is the same, step 3 is the same, step 4 is the same of solving until you get to this step. Step 5 changes a little bit. Another one. This is the angle I'm looking at. This is adjacent. This is hypotenuse. Adjacent and hypotenuse is a ka. That means cosine of 43 equals 36 over x. Cross multiply, I get x times cosine 43 equals 36. Yeah, this one's level 2. It's a little bit harder. But I just have to divide by cosine 43. Leave me with x equals whatever 36 divided by cosine 43 is. I get 49.2. Okay, why don't you guys please do 10 and 11? Go. All right, let's see. Here's my angle. This is opposite. This is adjacent. Calling for a tangent. So the tangent of 72 equals 25 over x. Cross multiply. So x equals 25 divided by tan 72. And then over here, this is adjacent, this is hypotenuse. Cosine of 64 equals x over 11. This one's an easy one. .8. How do you feel about level 2 trig problems? 5, I think I got these. 3, I'm getting to know them. I'm getting more comfortable. I think I'll be all right. 1, there's something I'm missing from this puzzle.
Mr. Erlin?
Yeah.
I'm a little confused about 11. I got to x equals 11 over cosine 64. Why is it 11 times?
Well, it depends on this situation, doesn't it? When we say the cosine of 64, ka, equals adjacent over hypotenuse, we have to put the x on top and the 11 on the bottom.
Oh, okay, I see.
And for when we cross multiply, this one will be the level 1. It's easier version. Okay, so now we're going to look at some of the word problems. I'm sure these were your favorites from algebra as well. These are pretty easy though. Jake leaned a 12-foot ladder against his house. Oh, that's scamp. So let's say that this is the house and this is the 12-foot ladder. The angle formed by the ladder and the ground is 68. Well, this looks like the ground here, so this is 68 degrees. How far from the base of the house did he place the ladder? Here's the edge of my house. Here's the base of the ladder. And so they want to find out what this is. And we have to have a right triangle for this to work. So I'm assuming that this house was built perpendicular to the ground, right? I know that's an assumption we don't like to make in geometry, but relative to that 68 degrees, I have the adjacent and I have the hypotenuse. That sounds like a cosine. So the cosine of 68 equals x over 12. Cross multiply, x equals 12 times the cosine of 68, which means x equals 12 times 68 cosine equals 4.5 feet away. Last one on this page. It's asking us A ramp is used to load suitcases onto an airplane. Okay, so here's the little airplane door, and there's the ramp loading suitcases. If the cargo door is 7 feet above the ground, so this part is 7, and the angle formed by the end of the ramp and the ground, so that's here, is 25, how long is the ramp? What's that? So what do we set up here? Which trig function do we use? Let's find our right angle. Makes this the hypotenuse. Relative to that angle, this one's the opposite. This looks like sine. So sine of 25 equals 7 over x. So x times sine 25 equals 7. I want just x. This is x being multiplied by this mess, so I have to divide by it on both sides. And I get x is equal to 7 over sine 25. So x is about 16.6 feet. All right. We have one more page in this packet, which is designed to be your homework. I'm going to create breakout rooms now and send you into the rooms. If you're interested in asking help, just raise your hand.